So this is a pretty standard quadratic word problem you might find in the algebra class. They're telling us that the length of a rectangle is 4 feet less than 3 times the width, and the area is 55 feet squared. We're supposed to find the dimensions. Well, let's start with what we know before we panic. We know that if I have a rectangle, there's a length and a width, and the area is length times width. We need to start by trying to get this all in terms of one variable, and this is going to be our clue right here. The length of a rectangle is 4 feet less than 3 times the width. It's kind of a mouthful, so we're going to break this down piece by piece by piece. I'm going to keep in mind that the word is means equals. If I see less than, something is less than, I'm going to subtract. 3 times means multiply. So if I just read it piece by piece, the length means that L is means equals. And then I think I'll take this 4 less than 3 times the width. What's a sentence for that? Symbolically, 4 less than 3 times the width. It'd be 3 times the width, but then take away 4. So what we have here is another way to say what the length is. The length is the same thing as 3 times the width minus 4. I can take this expression and go down my area equation, and instead of saying L times W, I can use this in place of L. So that's going to look like 3W minus 4 times the width. This represents the area, which they told us is 55. So that's equal to 55. Now you might be thinking, what does this have to do with quadratics? Well, to solve this, I've got 2 kinds of W's here. They're being multiplied together. I can't just get this thing by itself. I can't just use reverse PEMDAS. All I could really do right now is distribute this W inside of these parentheses and then see what shakes down. So basically, I'm going to end up with a 3W squared minus a 4W equals 55. And now I have a quadrant. This is looking more like what we've been working on the last maybe couple hours. This is not a good candidate for factoring, probably. At least I don't want to try it off the bat. I'm not going to complete the square here because that lead coefficient is not equal to 1, so that's not a good choice either. So really, the best game in town right now is to get one side equal to 0 by subtracting 55 from each side and getting something like this. Now we'll just take what we know and we'll take steps to solve this quadratic. I'm going to pause the video while I do that because there's a lot of weird noises in my backyard right now. It turns out that the square root of 676 is 26, so I'm going to get 4 plus or minus a regular old 26. The square root symbol's gone because I took it, all over 6. And I'm starting to run out of space here, but if you solve this thing down, let's see, 4 plus 26 is equal to 30. Divided by 6 is equal to 5, so the width is either equal to 5 or 4 minus 26 is negative 22, divided by 6 is some negative number that I don't care about because the width will not be negative. So now I know the width of the rectangle is 5, and now I can use that information and this information to find the length. The length will equal 3 times 5 is 15, minus 4 more is 11. So those are the dimensions of the rectangle. And just as a quick check, is it the case that a 5 by 11 rectangle will have an area of 55? Totally, that is true, absolutely. And is it the case that this number is 4 less than 3 times that number? Totally, it's true. So you just got to kind of think it through, talk it through, stay calm, get it to a problem that you know how to solve, and then solve that problem. Trust yourself, stay calm, persist, and be awesome. Good luck.